So imagine this. You've got two full high-def broadcast feeds coming from a stadium, maybe 100 kilometers away.
Right.
And you need to get them back to your control center. Copper cables,
Yeah.
they're just not going to work.
Not a chance. They'd fail almost instantly over that kind of distance.
Exactly. And that impossible gap is what we're getting into today. Our focus is on the Thor broadcast F-2ASI, a really specialized bridge unit.
And it's so much more than just a repeater. I mean, you can think of it as the definitive copper to fiber media adapter.
A media adapter for the backbone of broadcasting.
Precisely. It's for those critical signals like DVB ASI and SD-SDI where you just can't afford any signal loss.
Okay, hold on. You mentioned two different signals there.
Wait.
DVB ASI and SD-SDI.
I did.
Those are, well, they're fundamentally different streams, aren't they? One's for compressed MPEG, the other is uncompressed standard dev video.
They are.
So does that mean there are limitations? Like, can you only run one type at a time, or are these two channels really and truly independent?
No, they are absolutely independent pipes. And that's the core engineering insight here.
Okay.
The unit takes two BNC inputs from the copper side, and it frankly doesn't care if one is a compressed stream and the other is uncompressed.
It just sees data.
It just sees data, and then it does something incredibly efficient. It multiplexes both of those signals onto a single fiber.
Ah, so that's the real trick. It's not just transmission, it's consolidation.
Exactly.
Because if you're running two, say, 622 megabit per second lines, you are literally cutting your cost for leasing dark fiber in half.
You are. You're only paying for one strand. Think of it like this. The copper is a two-lane local road.
Okay.
This unit is the on-ramp, and the single fiber is a super-fast tunnel that gets both lanes of traffic to their destination without them ever merging or colliding.
And what about actually setting this up? I mean, in a high-pressure environment, the source material says it's plug and play.
Right, which is a huge deal.
But what does plug and play really mean for something this critical? Is it just that the lights are easy to read, or is there no complex optical configuration?
It's more about simplified deployment. It means the unit is smart enough to handle the optical handshaking on its own.
So the engineers can focus on the content?
They can focus on what's coming in and what's going out, not getting bogged down in network layer management. Plus, there's an option for bidirectional transmission.
So you can send signals both ways on that same single fiber?
You can. Total flexibility.
Okay, that makes sense. So let's talk about the scale, the actual performance. The bandwidth support is pretty impressive. It says here from 0.5 milliPs all the way up to 622 milliPs per channel.
Per channel. Which is more than enough for things like SMPTE 310M, multiple HDTV streams, video on demand. It can handle it.
But the physical distance is what's really wild to me.
It is. Copper gives you maybe a couple hundred meters. This thing, standard, is rated for 20 kilometers.
20, okay.
But it's capable of reaching up to an incredible 110 kilometers.
110. Pushing two full data streams that far just sounds like a massive engineering challenge. How does the signal not just degrade into nothing?
Well, it all comes down to the quality of the optics and, crucially, the fiber itself.
Ah.
You can only get that kind of range using 9125 micron single-mode fiber. If you try to use cheaper multi-mode fiber, you'd be lucky to get 2 kilometers.
So the hardware and the type of fiber cable are what make it possible.
That's what prevents the jitter and packet loss over those huge regional distances.
Right. That puts it all into context. And just to wrap up the tech specs for everyone listening, you've got those two BNC ports for your copper inputs.
Correct.
And the main optical port is a standard STPC connector, but you can get others if you need them.
Yeah, SC or FC connectors, depending on what your existing fiber setup requires.
So when we tie this all together, this F-2ASI is a perfect example of specialized hardware that isn't just about transmitting, it's about efficiently consolidating.
That's the key word, consolidation. It lets you run what are essentially two separate networks, say a live broadcast and a VOD service, through a single shared fiber line. And that really brings up a final thought for you to consider. If you can consolidate two full data centers onto one tiny thread of glass and send it across a whole region, what happens when you need to scale beyond just two channels? And how quickly will the industry make the single strand efficiency the absolute standard for everything we do?